So today we're going to talk about parallel and perpendicular slopes, and then ones that aren't. Clearly it's more common that they're just going to be intersecting, like this bottom graph here, where the slopes are different. Parallel lines have to have exactly the same slope, as you can see right here. Perpendicular are the ones that are a little trickier. They have to be opposites and reciprocals. So let's talk about an example of a perpendicular one. So fraction 3/4, and its reciprocal would be 4/3. And again, one of them would have to be negative. It wouldn't matter. The 4/3 could be negative, or I could have the 3/4 negative. Either one could potentially be negative. Just they have to be opposites, meaning one's positive, one's negative, and they also have to be reciprocals of each other. Okay, so that's the definition of what parallel and perpendicular are. All other lines are intersecting. So then, again, we're going to just fill in those definitions. Parallel lines have the same slope. Perpendicular have opposite and reciprocals. All of the lines are just different slopes. And to find the slope, you can always find the formula. Now, as we look down here, this first one clearly has a slope of up 2 and over 1. The other one also has the slope of up 2 boxes and over 1. And as you can see, since both of the slopes are the same, you're going to click parallel. When you look at the next one, you can see, let's let this graph go in a lot. You can clearly see that it's down 8 and over 8 on the red. On the blue line, it's up 8 and forward 8. So when you work those out, negative 8 over 8 reduces to negative 1, and 8 over 8 also reduces to positive 1. And if I were to reciprocal those, they would still be 8 over 8, right? So that makes that perpendicular, because one of them is positive and one of them is negative. All right, so the last one is just an example, and at this time I'm not even making you count the slope, I'm just needing you to identify the m in the equation. So clearly in the pink equation it's 3, and in the kind of brownish orange equation it says negative x. And if they don't put a number in front of there, we would assume it's negative 1. And since the slopes are different, clearly that would be intersecting. So we look at our first example down here, you'll notice that I've given it to you in every way possible. Line 1 on the first example is just y equals mx plus b, so our slope is 2. On line 2, I gave you 2 ordered pairs, so you actually have to calculate it. So 5 minus 3 is 2, and 7 minus 6 is 1. Again, those are identical. 2 is the same as 2 over 1. So you're going to circle here the parallel, and you're just going to tell me that they're the same. On the second one, I gave it to you in a lot harder method. I gave it to you in point slope format, and I gave it to you in standard form. So clearly, point slope form, the slope is right there. It's negative 1/2. It's circled right there in the equation. But when it's in standard form, you have to put it in y equals mx plus b form, and I did that as I subtracted my 5x. I divided everything through by negative 12. I ended up with 5 over 12 as my slope, and clearly that is intersecting because neither one of those are equal, and they're not opposites and reciprocals. Otherwise, they would be perpendicular. So again, you're going to then do the other problems as you go through them and solve the problems. So again, don't forget the definitions of the 3 types. Intersecting is most of them. Perpendicular can only be the ones that are opposite and reciprocal, and parallel have the same slope.